ado, it is my pleasure to introduce our guest this evening, who I am super excited to have with us. Ethan Siegel is a PhD astrophysicist and author of Starts with a Bang. He is a science communicator who has taught physics and astronomy at various colleges. He has won numerous awards for science writing since 2008 for his blog, including the award for Best Science Blog by the Institute of Physics. His two books, Treknology, The Science of Star Trek from Tricorders to Warp Drive, and Beyond the Galaxy, How Humanity Looked Beyond Our Milky Way and Discovered the Entire Universe, are available on Amazon, and we'll probably hear more about those later on. And I think he'll tell us a little bit about his blog, too. So, Ethan, welcome to the show. Thank you so much for joining us. How are you today?
I'm doing well today. Thanks for having me here. I hope everyone can hear me okay. I haven't bragged about it too much, but I do have a third book out now, which is my very first children's book. This book is called The Littlest Girl Goes Inside an Atom, and it is not yet available on Amazon, but you can order it at thelittlestgirl.com. So, this is really cute. I've just recorded the audiobook version from it. The illustrations inside are wonderful. It is full of pizza and gluons and a little girl who goes inside atoms, and
I need to find a small child to do that journey. Book too.
Yes.
This is a pretty good one, but believe it or not, I didn't actually come here to self-promote. I came here.
It's okay.
You can promote. You can push yourself. It's fine.
We love books here.
But I came here because Helen had met me on a different podcast and asked me if I would come and talk to you folks about the importance of science and who science is for. Because I know a lot of people who have particular types of religious upbringings or live in certain communities with certain beliefs, feel that science is not for them. And even later in life, if you intellectually know that science is for you, some people still don't feel that internally. And I thought that this was a pretty important topic to come and talk about. I had, if you had asked me, not in this context, what science is, I would have told you that it's two things together. That on one hand, it's the full suite of scientific knowledge that we have. It's all the facts and the observations and the measurements and the experiments we performed and what their results were. It's all of that grouped together on one hand, and it's also a process on the other hand, that it's a process of investigation, of making hypotheses, of testing them, of refining your results and drawing your conclusions based on all of this mountain of facts that's over here. But for this audience in particular, I think it's important to realize that science is also a third aspect. It's not just a body of facts, and it's not just like a way of thinking or a process. It's also a resource. Science is that deep resource that if you have questions about anything in or out of this world, there is a scientific answer, or at the very least, there is a scientific, here is the best that science knows about this right now, that it can always tell you and that you can use as a resource for yourself when you're trying to figure things out. I have a lot of things that I think go along with this, but one story that I thought that I'd share with all of you is a few summers ago, a friend of mine needed help bucking the hay at his property. He has cows, he has grass, the grass grows, you have to, cut the grass, dry it out into hay, bale the hay up, and then buck the bales of hay into the barn so all the animals have, stuff to eat during the winter. It's part of what you do. So I go over to help him out. My friend is a PhD in hydrogeology. I'm a PhD in astrophysics, and he has a couple of young high school graduate kids helping out too. And one of the high school kids, unbeknownst to him, starts talking to me about how the Earth is flat, that the Earth is young and it's 6,000 years old and it's flat. And I said to him, well, how would you know? And he was like, what? And I said, well, some people say the Earth is round. You say the Earth is flat. If I wanted to find out, how would I find out? And he was surprised by this, and he thought about it for a second, and he was like, see, that's what I'm saying. That's what I'm saying. That's what they should do. They should find out. They should find how to find out if it's round or if it's flat. I'm like, well, that's not something, that we need to wait for people to find out. People had answered this question thousands of years ago because they went and found out. So that's what science is it's this approach to the world where how do you find out in the absence of knowledge? And this could be in the absence of all of humanity's knowledge, or it could just be in the absence of your own knowledge. It could be in the absence of your own knowledge. If you don't know, how would you find out? Now, there have always been people since long before the Bible was written that said, all of the answers you need are in this book, right? Plato, writing about Socrates, wrote a whole play about Socrates arguing with someone who was certain that the answer to everything you needed to know in life was located in the Iliad and Odyssey. That if you just read your Homer, that you would know everything there is to know about everything. And so even before the Bible was written, even before we had the New Testament of the Bible, before Christianity was a thing, because this is hundreds of years before the time of Herod and the Roman Empire, you had people in the 5th century BC saying, oh, everything I need to know is in this very old book. Everything I need to know is in this very old book. And Socrates, one by one, would sort of pick apart that argument. Like, here are some things we know now that they didn't know in Homer's day. Like what? Like how to make iron. I don't know, lots of things. Technology advances. We know things that we don't know back then. And so this is a line of thought that I think is very powerful for us, that we shouldn't underestimate the power of finding things out for yourself. Just because something is new doesn't mean it's to be feared, right? And we know we all have limits to our own knowledge and our own experience. I'm a scientist, and I bet you that if you look at the things that I know the most and you're like, oh my God, how does anyone know that much? That I look at that and I say, oh my God, look how much I don't know. Look how much nobody knows, because I've studied it this hard and we still don't know because the data doesn't exist to draw a conclusion. The information isn't yet known to humanity. But these are the key questions. This is how we advance science for the world, is we say, if we wanted to answer this big question that we have, if we wanted to answer these questions that we have, how would we do it? Well, for the Earth being round, there are, of course, a few famous ways to do it. You can change your latitude and look at how the sun's position changes or how the shadows cast at noon change. You can circumnavigate the world. You can fly up off it high enough in a plane, a rocket, or whatever, and see that it's physically curved for yourself. You can set up a big pendulum and watch how it precesses based on latitude, like Foucault did, back in the 19th century.
Not Michel Foucault, a different Foucault, yes?
Yes. Although I wouldn't be surprised if his name was also Michel. Popular
Oh
name.
no, that would be so confusing. Now we've got to get more book recommendations. Stand by while I Google.
Yeah, I will. You might tell me that it's the same Foucault after all. I don't know.
Car is our resident bibliophile. So.
Yeah,
yes, I
I'm
am.
not
I
a
get excited
historian.
about
I
that.
just read and tell stories. It's not the same. I don't look
Yeah.
into it. My pro job is astrophysicist, and that's mostly what I write about. But like everything, you got to recognize there are limits to your own knowledge, and where that knowledge ends for you, that's where doing science begins. It's one way to investigate the universe or the world around you. And I would emphasize that regardless of whether you're religious or not, whether you're atheist or not, whether you're ex-religious or not, whether you were religious, became an atheist, and now are religious again, but it's a different kind of religious than the first kind was, all of that, it's for you. Science is for you. Science should be a resource that's a part of your toolkit. However you approach it, the world is something that is knowable and measurable. And if you don't know about something, you can go and find out. You can go and investigate, what is it that we know? How do we know it? And how would I figure it out for myself?
I love that approach to science, and kind of you're coming at it with this curiosity, with the understanding that, yes, the point is that there are so many things that we don't know. You're not showing up with the book full of the answers to all of life's questions. You're showing up with a way to find answers to questions. I think that is such a good distinction. I love that. And also, it's Leon Foucault, so we're good.
Nice. Thank you, Leon.
Yes, I love that.
He's the professional and the pendulum guy, right?
Yes, that's the pendulum guy. So, now I'm going to have to read more about that. But so tell us more about, how can we access this? Let's say we're just regular people who maybe didn't grow up with a lot of background in science. How do we know if these questions have been answered, or how do we access this process to find things out?
I mean, back in the day before the internet, I would have said that, oh my goodness, the library is full of these sorts of resources, because that is where you would go to say, well, if something is known in the world but not known to me, where do I go? And the answer is a library. And believe it or not, if you still have access to a library, librarians are incredibly useful for helping you find this sort of information. But if your library is closed, or you only live near a Christian Science library, or there are certain, restrictions on what books your library can carry, which exists in some places, you can say, okay, look, I need to figure this out on my own. The thing is, we all use shortcuts, right? We all have experts that we go to. We all say, like, here's who I trust. Here's who I think has it right. For me, I don't like to do that. I don't like to trust one authority. I don't like to say, oh, I like what this person says about thing A, so therefore I'm going to automatically trust them on B, C, D, E, on all the other things. A lot of us, I think, are sort of taught that that's what you do. I think a lot of us are taught to be that way with our parents, that when our parents tell us something, they're the authority figure and they're right, and we should listen to them. Which means if you say, like, what's a human body made of? And they say, oh, it's modeled out of clay, then we're going to go and tell our science teacher that the human body is made out of clay, which I've had students tell me. We're going to go to our we're going to say that, when you die, you lose weight because your soul leaves your body, and the soul weighs this much, and you actually lose mass when you die. And it turns out that does not happen. That 21 grams thing is a total myth. But people believe it because they're told it, and they'll repeat it. And when you tell yourself a story over and over again, it becomes true to you in your head irrespective of whether it's true out there in the world or not. And that's a dangerous thing. I think a lot of the trouble people have is not with science or what science says or what science tells you the world is like. It's because the lessons we learn from science replace not a vacuum of, oh, we didn't know what was happening for some people, but it's supposed to replace, or it's at odds with, this other thing I was taught that I'm supposed to accept as true. Now, you might think like, well, how does science help you with that? And the answer is, science is tremendously helpful for that. If you've ever asked anyone, hey, how do I reconcile, you physics guy, you know something about quantum mechanics, how do I reconcile this insane, unintuitive quantum universe with the seemingly deterministic macroscopic universe that I have? And the answer is, oh, well, I have to understand that I have certain rules or models of reality that apply only over some range of validity. When I'm working over here, I use these rules and they work well for all of this stuff. When I'm working over here, I use these other rules that work well for this other stuff. And in the in-between area, that's like the frontier. That's what we're still working on. Science doesn't have all the answers, and it never will. There's no, despite what some people say, and, beware what people are selling, right? Despite what some people say, oh my goodness, there's actually a link to the 21 grams experiment appearing in the chat. So if anyone actually believes that, feel free to follow that. That's very fun.
If it's Rob, and he's a volunteer here, so I'm using his name. He is our expert wiki person of debunking.
He actually does this for fun and goes and fixes, sometimes in real time. He fixes up wiki pages. So thank you, Rob.
So on that note, so for people that don't know how to vet sources, like they're just learning a science education, and they're trying to figure out, well, how do I look up this information? How do I know the source that I'm getting is correct? How do you tell someone, like, the average person that might be listening to this podcast, how to go look up information like evolution? Where do you go to look up information on evolution?
I mean, I would say, honestly, this is going to sound super naive, but if I didn't know anything about a topic and I wanted to find out approximately what's true about it, where do I start? My first starting point these days would be an encyclopedia like Wikipedia. Generally, if I have a broad topic that I want to look into, Wikipedia is not going to have all the details right. It's not going to have everything up to date. It's going to have a few mistakes that some pros make, especially older pros who learned their science decades ago and maybe haven't kept up with the latest developments. So there'll be some, details that it doesn't have right. But for a broad first step, Wikipedia is generally very good. I would have said a few years ago that it's generally pretty good. And I think my opinion on that has changed. I think it's actually become more comprehensive. For example, if you go to my Wikipedia page, I think 90% of what they have on there is correct. And I'm not going to tell you which 10% is wrong, because that's not what I do.
Oh, come on. Yeah, that would ruin all the fun. Well, I love it.
If you're someone who values your privacy, then you might not be so disappointed when you find that there's a bit of misinformation associated with your personal information up there.
Yeah.
Completely fair.
Yep.
Completely fair.
ChatGPT, if you're wondering, makes all of its stuff up. In fact, they just revealed what the largest language training data source was for ChatGPT, and the answer was a fan fiction website. that
Oh
ChatGPT learned
no.
most of its language from a fan fiction website.
That
Oh
is
no.
incredible.
That's
And
awesome
this
though.
this is something we've been
Yeah.
talking about in the Hangout a few
Yep.
times lately with I'll pick on Rob again, one of our other co-hosts. He found out that ChatGPT was making up information about him
Mhm.
also and saying he had written
Oh yeah.
articles that he had not even written. So
My
this is
boss
interesting.
asked ChatGPT about me at work, and it told ChatGPT that I won this prestigious award. And I told him, I didn't win that award. I give that award. I'm the judge for that award. I've judged that award for the last 8 years. Um, then it told me about some famous thing that I wrote, and I'm like, I never wrote that thing. That thing doesn't exist. It made the whole thing up. So
Wow.
do beware of sources. If you're going to ask Chat GPT or some artificial intelligence, right, don't ask Alexa or Siri. Like, Siri,
Mhm.
is evolution true? Like, Siri might tell you something, and it might be true or not, but Siri would not be my expert source to go to. But at a basic level, simply checking out an encyclopedia, and Wikipedia is a perfectly good encyclopedia, maybe the best one out there. That's going to be a great first starting point. If you're looking into a contentious issue, though, like something that is permeating the discourse in America or in the world, um, I would really caution you very strongly to stay away from any news outlet that also reports on politics. There is a saying that politics poisons everything. And for me, this is especially true when it comes to something that's scientific, because politicians, people who have a political agenda, will focus on one aspect of an issue in order to get their way, whatever their way is. You have to realize in science, there's one question we care about more than anything else, and that is simply the answer to the question of what is true. That's what we want to
Mhm.
know as a scientist. We're not interested in who said or how authoritative they are or what else they've also said that's correct. Or no, we want to know what is true, which means if we took everything we knew about it, we incinerated it, and we killed everybody who ever knew anything about it, and we started over from scratch, science would give us the same answer if we started all anew and said, we're going to go out and ask of the universe, what is the answer to this question? How do we're going to come up with a way to measure it, to experimentally test it, to go gather observational evidence for it. We're going to go out into the world. We're going to measure and test this thing. Up until the 1900s, we didn't know that there were any galaxies in the universe other than the Milky Way. Most people at the start of the 1900s thought that the Milky Way was the entire universe. We did not know
Yeah.
that the universe was expanding until the 20th century. We did not know that the Big Bang was the origin of where our universe came from until the second half of the 20th century. So, all of these things, for countless generations of humans, these were questions. Where did we come from? How did we get to be the way we are today? What is the universe like? And what is our ultimate fate, however far we ask from now? This is something that for all of human history until the 1900s, that these were imponderables. These were things that poets wrote about, that theologians and philosophers pondered, and now we have scientific answers to them. I think that, science is for everyone, whether you're religious or not, and regardless of how you're religious. But I do think that science has to act independently of anything else. You can't say, as Pope John Paul II said to Stephen Hawking, oh, don't research that, that's off limits. You can't say that. Nothing's off limits to research when it comes to knowledge. We want to know all of the secrets of the universe. We want to know all that there is that's knowable out there. And the only way to do that is by asking these critical questions.
And I feel like that's also a great way to dare somebody to study more on that topic as soon as you tell a bunch of researchers who are curious about things. Don't look into that. That's probably the best way
Which
to.
is the thing that I'm immediately going to do.
Yes.
Don't tell me
Yeah,
not
I
to
mean,
do
well,
something. I'm
usually
going to
when they
do
say
it.
don't look into that, sorry, dude, that ship sailed. You don't even know how long ago. We've been looking into that for a very, very long time. Like, don't ask what came before the Big Bang. Like, oh, my Pope, my dude, that ship has so sailed. That ship sailed before you were El Papa. That ship sailed a long time ago.
Ooh, well, okay, that brings up an interesting point then. What can you tell us? Some interesting tidbits or topics or misconceptions that people may not be aware of that we have research or knowledge about when it comes to, particularly your field, astrophysics, the cosmos.
I would
Break it down
say
for us.
the two biggest things that people don't realize that we actually know is that all of the stuff that makes us up, all the matter that makes us up, this normal matter made up of atoms, protons, neutrons, electrons, if you take all of the known particles in the standard model, everything we've discovered at particle accelerators, from cosmic rays through nuclear experiments, all of these experiments that we've done, and you take all those known particles, all the quarks, all the leptons, photons, neutrinos, all that stuff, and you add it all up, that's only 5% of the total amount of stuff in the universe. The rest of the stuff that is out there in the universe governing how it gravitates and expands and clumps together and recedes away from each other are these two mysterious components called dark matter and dark energy. And these were discovered in the late 20th century. And we're still, like, although we can say a lot of things about what their properties are, we're still trying to puzzle out exactly what they are. Can we interact with them? Can we directly detect them? Can we only detect their influences on things? But these are two facts that really aren't in dispute. These two things exist, and they're most of the energy in the universe. What are they? That's a big mystery. But I think another thing that people don't know that would blow their minds is a lot of people, when they hear about where did the universe come from, they sort of set it up. Okay, well, either like blah, 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 Big Bang, or God made it. And those are the two options. So over here on the Big Bang side, we haven't thought the Big Bang was the very beginning of the universe since the early 1980s. In the early 1980s, we came out with the theory. The whole thing about the Big Bang is we say, okay, look, today we see that the universe is expanding in all directions. Like you had a giant ball of raisin bread dough in space, and it was just leavening in the vacuum of space. So it's all expanding in all three dimensions, and these raisins are like individual galaxies. They're all receding away from each other as the dough expands. So you say, okay, well, if it's expanding and leavening today, then what was it like in the past? And you would say, oh, well, it was smaller and closer together. And closer together in a smaller volume of space means more density. And it also means because there's light in the universe. And light, if you remember your physics, or you never learned physics and you want to learn it for the first time now, light's energy is defined by its wavelength. Longer wavelength is colder light, and shorter wavelength is hotter and more energetic light. So as the universe expands, it stretches the light to longer wavelengths, which is why we can see the leftover glow from the Big Bang hanging out in all directions in space at just below 3 Kelvin, 3 degrees above absolute zero. That's how much the universe has expanded by since it was hot and dense. But that's what it means, is in the past, the universe was hot and dense. So when we look at, if the universe was hotter and denser, then maybe we can go hotter and denser and hotter and denser and poof until everything was at a single point in space.
Mhm.
And when you start doing that, you start saying, oh my God, well, look, that means that there's a birth of space and time, and that's the original idea of the Big Bang. But that doesn't quite work out. That doesn't quite work out in detail, because if you extrapolate all the way back, you're forced to ask yourself questions that you can't answer. Like, okay, look, if everything started off from the same point and it expanded and cooled ever since, then the stuff that's over here and the stuff that's over here, 46 billion light years away in this direction, 46 billion light years away in this direction, the universe hasn't been around long enough since the Big Bang for those two regions to have exchanged information with each other. It's sort of like if you put a space heater in one corner of your room and you wait until the room becomes an even temperature, you have to wait some time because the molecules in that corner of the room have to circulate throughout the whole room to heat everything up. How did the universe know to be the same temperature in all of these different regions on all these different parts of the sky that have never had a chance to talk to each other? That's kind of weird. Also, the expanding universe, if you start it with the Big Bang, it's like a race. It's a race between whatever the initial expansion rate was, which works to expand the universe, and whatever the full sum of all the gravitating stuff in the universe is, right? That's going to work to pull it back together. You can imagine like the Goldilocks story. Well, it could either be the universe could be, too much, right? It could be expanding too fast and poof, it expands away into oblivion. Or it cannot be expanding fast enough and poof, it recollapses and ends in a big crunch. Or it could be just right, and you can live right on that edge, right on that border between expand forever and recollapse. And for some reason, we're right on that Goldilocks border. Why? We look back at the early universe and say, yeah, in the early stages of the Big Bang, if you take the expansion rate and the density of stuff in the universe, they need to match to a precision of 51 significant digits, which is like writing 1.0000. You need 50 zeros before the next number is allowed to not be zero. Why was the universe like that? But for me, the biggest thing is, look, if the universe started out at these arbitrarily high temperatures and densities, then where is all, we know particle physics isn't done. We know we haven't found all the particles that are out there. There's some super high energy at which more particles should exist. Where are they? If the universe was this hot in the past, it should have made them. Where are they? All the theories predict them. They're not here. Something must have happened. So these were some big puzzles people were thinking about in the 60s and 70s. And in the early 1980s, a scientist at MIT named Alan Guth came up with an answer. He said, hey, what if the Big Bang wasn't the beginning? What if this hot, dense, expanding state only arose in the aftermath of something we call cosmic inflation, where instead of being filled with matter and antimatter and energy and all of this stuff, the universe just had a large amount of energy bound into empty space itself. Well, then it would expand exponentially, which means relentlessly, and just be empty, making empty space, making more and more and more empty space until somehow inflation comes to an end. And then all that energy that's in the space that had been making it expand gets converted into matter and radiation. That's brilliant because that solves all the problems. It says, oh, well, the universe is the same temperature here and there because it all arose from this inflating state in the past where they were together, driven apart, but got imprinted with the same information. The universe is flat because inflation stretched it flat. Imagine taking something like a beach ball and blowing up the beach ball so that it's 100 billion light years wide, right? Just huge. When you look at that beach ball, what are you going to see? The part of it that you see is going to look flat Just like if I told you, hey, go out into your backyard and measure the curvature of the earth. You can't do it. It's indistinguishable from flat. Just like if I gave you a Pringles chip that was the size of the solar system and said, hey, is this chip flat? Well, from where you're standing, it looks flat. It's not flat. It's shaped like a saddle or a Pringles chip, right? Negative curvature like a Pringles chip, positive curvature like a beach ball or a globe, or flat. You can't tell because inflation expanded it so big that that little part you're in now that you call your universe, you can't tell whether it's flat or not. But it also explains that there's some maximum temperature the universe could have reached. It's not arbitrarily high. It's not infinite temperatures. And that's something we can actually measure by looking at the leftover glow of the cosmic microwave background. And we have confirmed, along with 3 other predictions about the types of quantum fluctuations that inflation produces that seeds the large-scale structure of the galaxies in the universe. Inflation is 4 for 4 on these testable predictions, and the hot Big Bang without inflation is 0 for 4. So even though for most people they think, oh, the hot Big Bang, that's the start of it all, that's something that I think even Wikipedia is behind on. I still think Wikipedia puts the Big Bang before inflation. That is not true. That has not been true in the astrophysics community. These predictions were all made in the 1980s. And they started to be observed and borne out starting in the early 1990s with missions like Boomerang, the COBE satellite, the WMAP satellite, and then the Planck satellite, and large astrophysical sky surveys like the Sloan Digital Sky Survey. All of these predictions of inflation that have been tested have been confirmed. And although, you can always find astrophysicists who disagree with the consensus, they're in the vast minority. We're talking more than 95% of working astrophysicists all say, look, dark matter, real. Don't know what it is, real. Dark energy, can't deny its existence. Yes, we have all the puzzles, but dark energy is definitely real. And cosmic inflation is what preceded and set up the hot Big Bang, that you can't say Big Bang singularity anymore. You have inflation before the hot Big Bang, and who knows what came before inflation. But I think it's sort of this wonderful example that all of this science, all of these scientific frontiers that I'm talking about are built on the foundation of all of the science that came before it. We would not have developed the inflationary theory if we hadn't had the Big Bang, and we wouldn't have had the Big Bang if we didn't have general relativity before that, and we wouldn't have had general relativity if we didn't have Newtonian gravity before that, and we wouldn't have had Newtonian gravity if we didn't have Kepler and Copernicus, and we wouldn't have had Kepler and Copernicus if we didn't have Ptolemy and the geocentric model. So you can go all the way back and say like, oh, they were wrong in the past. Like, yeah, there's a right way to be wrong. The right way to be wrong is to say, I went out, I observed the universe, I made a model of reality. My model agreed with reality to the best that I could observe it. And then later on, we found, oh, there are corrections to this. This isn't universal. This isn't how it works for everything. There are these exceptions. We left the range of validity of the theory. That's great, because you don't always know what the range of validity of your theory is until you step outside it and go, oh, that didn't work, right? Evolution is a great theory. Doesn't evolution explain the origin of life? No. Evolution only tells you once you have life, how it evolves. The origin of life is outside of the question of evolution. So when you start, life is full of people who are just waiting to ask you these gotcha questions. And science, I don't play science that way. I think science is we all have a time in our lives where we are hearing about or learning something for the very first time. And that's kind of a very wondrous time for each of us. I remember I was in my early 30s, and I finally learned that my whole life I've been tying my shoes wrong. I've been tying my shoes into granny knots my whole life. And, because there's basically two types of knots you can make, depending on whether you go or over with your right hand or over with your left hand with the first lace, and which hand you make the loop with that you go around and pull through. And half the ways you can do it will make a nice squared up knot that will stay tight all day. And the other 50% of ways to do it will result in a knot that means your shoelace will work itself undone in very short order. And so what happened? When I was 30, I had to break it down for myself. I was like 31, 32. I had to break down, what am I doing? What have I been doing wrong since I was 4-something years old? And I learned to tie my shoes. And I had to okay, no, with the left, not the right, and pull. And, it took me like 7 weeks before I had trained myself to not by default keep trying the wrong way. But also, now I can tie my shoes correctly. And unless you get a venue like this where I admit it to everyone, no one needs to know.
Well,
okay.
We're all sitting here going, am I tying my shoes wrong? But I do have, Cara, you go first, but I have two things I need to say. And I have one thing to say, and then I have a question.
Okay, I will
Dark
real
matter,
quickly jump
dark
in here.
Energy, inflation, shoe tying.
Yeah.
I need to know if I'm also tying my shoes wrong, and there seems to be quite a few people in the chat who are also now quite concerned about this. Can you tell us, how do we know if we're tying our shoes wrong?
Scientific way to tie your shoes, even tell us.
Let me, you two amuse yourself for a minute. I believe I wrote an article about this a long time ago that might still exist on the internet.
Yes, please. We must have this. Now that I know, I'm sure I'm doing it wrong, because I'm also left-handed, which means I do everything backwards. So
I am also left-handed.
Well, you're the devil card.
All right, I have it documented. It was in February of 2012. So I was 33 years old when I learned how to tie my shoes correctly. And
awesome.
I need to have this in my life. I'll be checking this later, and we're gonna add this in the comments too, in the show notes. Like, this is something everyone needs. Are you tying
your shoes correctly?
Right. You thought you were gonna learn about the origins of the universe and what science education has to do with religion, but the main thing you're gonna take away is how to tie your shoes. You're welcome, internet. But okay, Helen, go with your question.
So, one, why do I feel high and I haven't smoked anything? And two,
you're getting a contact high from hanging out with me. I'm just coming from Washington State, where it's all legal.
It's that universal energy, man. It's just like, do stuff in my brain. Anyway, but what I want to ask you, so as a scientist and someone that actually does this sort of research, when you thought about people that have like this, and I'm not even a religious belief, but someone that is so attached to an idea that they don't want to separate from the idea because it becomes a part of something they understand about themselves or something they want to be true. I
hate to tell you this, because this is something that scientists do all the time.
I know, that's why I'm asking.
It's a problem that we have too. There are all sorts of examples of brilliant scientists throughout history who've made tremendous contributions to their field, who then could not accept some new discovery. Fred Hoyle was the person who discovered how heavy elements are built up inside of stars in the universe. He actually predicted that inside of red giant stars, there would be this process where 3 helium nuclei fuse together into an excited state of carbon to produce the carbon in the universe. That state of carbon, that excited state, it wasn't known to exist. Hoyle predicted that it must in order to produce the carbon in the universe. It does exist. The process is now known as the triple alpha process. The state of carbon is now known as the Hoyle state. But Fred Hoyle, that same Fred Hoyle who did that prediction in the 1950s, couldn't accept the overwhelming evidence for the Big Bang, that leftover black body thermal glow of radiation that's omnidirectional, that's undoubtable, that's there, that was discovered in the 1960s. He spent the last 40 years of his life arguing against the Big Bang theory. And as the observations got better, he came up with more and more elaborate excuses, what some of us might call saving the appearances, where he just sort of where he basically massaged his alternative theory so that it wasn't yet inconsistent with the data. You were able to tell, like, dude, the day Fred Hoyle died, everyone stopped working on this. Everyone who was working on his thing stopped working on it the day that he died. People are going to remember Roger Penrose for inventing black holes. Roger Penrose has a theory that's an alternative to cosmic inflation and the Big Bang, and he's in his 80s, he's going to die, and when he does, everyone's going to stop working on that who's working on it, because nobody believes it except it's attached to a big name. Stephen Hawking was someone who never really agreed with cosmic inflation, but his research stopped being relevant right around the time cosmic inflation was discovered. He did phenomenal work in the 60s and 70s. None of the stuff he really did in the 80s and after is well known or worked on today, because it didn't lead anywhere. But that's why, if you look back throughout history, the scientist who I hold up as like a personal role model for me is Johannes Kepler. Kepler was a contemporary of Galileo. He is not as well known as Galileo.
I know who Kepler is. Just
okay, some of you know who Kepler is. I'll give you mad credit for that.
Thank you.
But here's what I love about Kepler. Kepler was not originally known for what he's known for. Remember, Kepler's known for his laws of planetary motion. Planets move in ellipses around the sun. Planets sweep out equal areas in equal time in their motions around the sun. And he came up with the relationship between the size of a planet's orbit, what we call its semi-major axis, which is, if you take the ellipse it makes, it's half of the longest axis of the ellipse, and the amount of time it takes to orbit the sun. That's why if you look at the planets today and you see how they're spaced, that's why they have the periods that they do, why it takes them the amount of time it takes them to revolve around the sun. So Kepler found these three laws, and these three laws paved the way for Newton to develop his theory of gravitation. But when Kepler started out, he was Tycho Brahe's assistant. And when Tycho Brahe died, Kepler put forth what his model of the universe was. He called it the Mysterium Cosmographicum. And it was this gorgeous geometric construction. He had said, look, there are 6 known planets in the solar system, including Earth. There's Mercury, Venus, Earth, Mars, Jupiter, and Saturn. And in the 1600s, that's all that was known. There was no Uranus, that wasn't discovered till 1781. There was no Neptune, that wasn't discovered till 1846. And there was no Pluto or anything else. Pluto was discovered in the 1900s. So what did Kepler say? He said, look, there are 6 planets and there are 5 what we call Platonic solids. These are 5 perfect solids in the sense that each face of this 3-dimensional surface is a regular polygon. You can make them out of triangles, and there are 3 you can make out of triangles. You can make a tetrahedron, you can make an octahedron, or you can make an icosahedron, or you can have the square, which can make a cube, or you can have the 5-sided pentagons that you can tile together to make a 12-sided regular solid. Anyone who's played Dungeons and Dragons and have your set of gaming dice, this is the shape of 5 of the dice, is these 5 Platonic solids. They're the only ones you can make out of it. And Kepler said, here's my model. I'm going to have a sphere that supports the innermost planet, Mercury. And then outside of that sphere, I'm going to circumscribe one of these regular polygons. And then around that regular polygon, I'm going to draw another sphere that touches it at all of the corners. And I'm going to keep doing this with a polygon inside and outside each of these spheres until I have my full stack of all 6 spheres that are holding up the planets around the sun. And that's my model of the universe. And it was beautiful and everyone loved it. And it was wrong. It didn't agree with the observations. It didn't even work as well as Ptolemy's old geocentric model. And this is what impresses me the most about Kepler. Kepler loved his idea. He had literally fallen in love with his idea, like so many scientists before and after him. But in the face of the data that didn't agree, he was able to put his own preferred model aside and look at what the data was telling him. And he was able to derive these correct laws of planetary motion based on the observation, in agreement with the observation. And he rejected his old idea because it didn't agree with his observations. And that part, that aspect of saying, oh, well, I had this idea, the data showed me that idea was not correct, but when I looked at how the data was incorrect, it brought me to a better, more correct idea. Arguably, it's not as beautiful, but beautiful is a very subjective thing. Does it agree with reality? That's the big scientific question. Does my model, does what I predict, does this theory, does this model lead to agreement with observation and experiment? If the answer is yes, then this is still good. If the answer is no, then we say, well, at least over here, we can apply it to this. And I think that's what we should aspire to, right? None of us should ever feel too proud to say, I was wrong. When we say we are wrong, it means we've learned something, that we can recognize what we were taught before, or what we had learned before, or what we had thought before isn't all there is, that there's a better way to do things, and now we do things this better way. And to me, that's what we should aspire to. That's what we should reach for.
I love that story. That is excellent.
I'm in a happy place.
Yes. And we say that here all the time. We say, let's get excited when we find out we're wrong about something, because that means we learned something. Now we know more. That's great. Yeah. I love that. Well, okay, this has been great, and you're definitely coming back again. We've decided that already, Helen and I, just amongst ourselves.
Yeah, you're voluntold, Ethan. I'm sorry.
Yes. But we want to have time for some Q&A because we have a ton of questions. But before we go to questions, do you have anything else that you want to tell us or share with us,
or plug,
or refer us to?
Oh, well, if you like hearing stuff about the universe, I do write about 5 new articles every week. I run the column Starts with a Bang over on Big Think. It's always free to read. You can sign up for a newsletter on the site. You go to bigthink.com/starts-with-a-bang, or you can just go to startswithabang.com, which is my website and has all the stuff that I do over there.
Excellent. I'm dropping that all in the chat. We will definitely send people over there. I've been looking at that this week. And also, I'm just going to say we haven't gotten a chance to talk much about it either, but your book about the science of Star Trek is super fun. I cannot get over how much fun that book is.
I'll tell you the brief story behiund that if you want.
Yes.
I grew up as a Star Trek The Next Generation kid. It came out when I was, a preteen, and as I was like going through my teen years and like the good seasons were airing, I was like, oh, this is amazing. And Deep Space Nine and Voyager came out shortly after that. And I remembered reading a book called The Physics of Star Trek by Larry Krauss when I was a teenager. And I've since grown up and entered the same field and even the same subfield as Krauss. And I was amazed looking back on Next Generation, which has been like, geez, well, I published the book in 2017 to coincide with the 30th anniversary of the airing of the first Star Trek The Next Generation episode. And the thing is, I was like, but I remember reading that book by Krauss, and we know so much more now, and we have so much more technology now. So why don't I say, hey, let's look at all the technologies that Star Trek, the original series, and Star Trek, The Next Generation dreamed up, and let's look at where we are today. How many of these are physically impossible still? How many of them have we actually determined, no, you can do this? And how many of them have we actually already either achieved or surpassed? And I'll tell you, it's very exciting for me. Of the 28 technologies we've considered in the book, 24 of them are possible or better.
What? That's
Holodeck
incredible.
and food dispenser, by the way, are two of the possible ones.
I need that in my life.
So how are we doing on transparent aluminum?
That one is actually surprisingly fairly good. We have made various aluminum alloys called alons that are transparent to a variety of wavelengths of light. And so it may yet come to pass that we have a variety of aluminum that is completely transparent to the full spectrum of visible light. So that is not something that's crazy. We have metamaterials that can bend light around them. And again, we're working on applying this to the full visible light spectrum, but that's your cloaking device right there. If you can make it look like the background is in front of you where you are by bending the light around you. Yes, this is a published
so we're
book.
gonna have to have like another
Treknology, and it is available everywhere books have been sold since 2017.
We're just gonna have to have a talk on your damn book, man.
Yeah, you're coming back.
Well, you demanded this topic, so this is what you get. You don't like why science is for everyone. Meh.
We're friends
Star
now,
Trek
and
next time.
I'm volunteering you. And when I volunteer things happen.
Yeah, no, I mean, why do you think I only have another half hour with you folks? Is because I got voluntold into something else around
That's
here.
right. So, okay,
Fair
we have
enough.
to go to Q&A.
Yeah,
okay, we're
let's
gonna
do
have
some
Q&A
questions.
before you have to go, and then this way we will plan a day for you to come back and do another talk. So let's go to Q&A real fast before we fall into Treknology shit.
Right. We're going to talk about that later in the hangout, just so y'all know.
Yep.
Okay, Helen, you want to go with the first question?
Yes. So, what if you've been brought up as a theist, now an atheist, and learning about evolution, for instance, for the first time, and come across misinformation, but don't know it is misinformation? How do we check our facts and make sure that we are learning is an actual fact and not misinformation? Sometimes even Google can give multiple answers and it can get confusing. So what do we do to know that we're getting accurate information?
So that's a hard thing because at my level, I get tripped up all the time. And so I have a personal network of people that I know. Oh, this is my friend who's an immunologist. If I have questions about how a virus is going to infect human cells, I'm going to ask her. Oh, I have this friend who studies molecular genetics of organisms. So if I have a question about inherited traits, I'm going to ask him. So that's the sort of thing that I would say, you need to be aware of where your expertise ends. You can be much more confident in a knowledge fact that you're given if you look into and you can see for yourself, oh, here's what they know and how they know it. Like they thought this, they looked at this population, here's the thing. So they did this experiment where they took the same bacterial colony, And unlike humans, where if you want to see changes over many generations, you have to go back and look at the historical records. But bacteria, some species of bacteria divide so fast that you can see them evolve for thousands and thousands of generations over a relatively short time. So what they did was they said, we're going to take the same bacteria. The way you take the same bacteria is you put it in a nutrient culture, nutrient-rich culture, where it doesn't have to compete for resources and it can just divide. And biologists talk about this. If you've ever dated a biologist and they're like, hang on, I know it's Saturday, but I have to go into the lab and divide my cells. Biologists have to divide their cells. Otherwise, the cells, if you don't divide them, if you don't take them from their nutrient-rich place and take a small population of them and put them in a new nutrient thing where they have virtually unlimited nutrients and no competitors, they're going to run into the edge of the wall. They're going to compete with each other. They're going to develop and they're going to evolve. Boo. So they took 3 identical initial populations and they put them in 3 separate dishes. And they took the environment that they were in and they gradually changed the temperature of the environment so that it gradually went up to temperatures that if you had just for a single generation raised the temperature to this, it would have killed all the bacteria. But they did it very slowly over the time span of thousands of generations, and the 3 different species of the 3 different cultures of bacteria all adapted to the changing temperatures. Then they did the same thing with these 3 populations again, and they gradually lowered the temperature. And they, sure enough, all of them, they didn't die out, like a bunch of them died, but they didn't die out. They also all adapted again. Then they went and they looked and they said, okay, now because we know genetics, we're going to look at how did the genetic codes of these different populations change? And the answer is all 3 species, when they turned up the temperature, they all made different mutations to adapt to the changing temperatures. Dish 1, dish 2, dish 3, 3 separate successful adaptations, all different from one another, all changed their genes in different ways. Then they lowered it down again, 1, 2, 3. All 3 again changed in fundamentally different ways to adapt to this. Now you have 3 populations that can survive in either high or low temperatures that all have different genes than the original population that they started from. That's an amazing experiment on adaptation that you cannot do in human beings. But for me, that was like mind-blowing to learn about. And that's the sort of thing that I think that if you can actually get dug into the science of, well, look, I had a question about this and I want to know, how do we know it? You know, and I think when you find these really key experiments that you can understand how the experiment was done for yourself and what the results of it were, I think that's really powerful. That's a really powerful way of saying, like, well, I just know too much. You can't sell me the disinformation because I'm too informed to actually fall for this misinformation.
Okay, that's a great advice and great story. Also, I love your stories. This is like science story hour. I am having a really good time with this.
Learn about science through stories.
Yes, I love this.
It's a lot better than reading a scientific paper for someone that's read scientific papers. Like just listen to people tell you science stories.
Yes, but I mean, this is the importance of having people like you who are science communicators and science writers and educators. So, I mean, thank you.
Well, you
for
know,
doing that.
They asked me, a lot of people, you know, of course, are like, you know, Ethan, you're not really a journalist. You didn't go to journalism school or get trained doing blah, blah, blah. No. And I said, look, you ever see the movie Miracle? Not the original 1980 Miracle on Ice, but the movie about it that was made like 20 years later. There was a huge debate over how they were going to make this movie. They said, what are we going to do? Are we going to get some big name actors to play the hockey players and bank on their Hollywood names? Well, we could do that, but then are they going to be able to play convincing looking hockey? Or are we going to get hockey players who've been skating since before they could walk and teach them how to act? What do you think is easier? to teach an actor how to play professional level hockey or to teach a hockey player how to act like a hockey player. So I think that for me, I look at myself as, yeah, I'm the scientist who spent a lot of time practicing communicating and telling stories, and this is as good as I am at it now. So is that good enough? I don't know, but I bet you it sure as hell is better science communication than the journalist who doesn't know a microbe from a micron. So
Yeah.
I'm
This
sure
this
that
is what they got wrong in the plot of Armageddon, where they had to pick between choosing astronauts or people who dig holes, and they
I can
went the
say
other way.
that like I had a really good science teacher when I was in high school, Mr. Slatus. And he was the first person to get me really into understanding science, because he didn't talk down to people. He didn't treat us like we, and he was able to communicate with like, this is something everybody can understand. Like, and that's what you want in a good science educator, to not make you feel like you're a dum-dum, to be like, hey, this is the hard stuff, but I'm going to communicate it to you that you can understand this. I'm like, explain it to me like I'm a 5, and then all of a sudden I'm like, oh, okay. And then you want to dive more into it. And I think that's great. So that's why I appreciate about you, Ethan,
well,
that you're
thank
able
you.
to communicate
I
it
tell the
very
joke
well.
that my job as a science communicator is to translate from physicist into English.
Yes,
Yes.
exactly. Yes.
And
I
we need
appreciate it.
that. Yes. Okay, and speaking of which, we have had several questions on this next topic that maybe you can clear up for us or tell us we
Sure.
don't know. There have been several people asking about aliens. Do you believe in aliens? What about all these programs on TV about things like ancient aliens? What about all the news
Lizard
reports that
people.
people have been saying about, UFOs and government reports about that? Where do you land on this? What's the likelihood, in your opinion?
I mean, I'm open-minded in the sense that if you present me with the compelling evidence, like show the compelling evidence, then I'll be like, oh, that's great. Now I'm going to change my opinion on what's out there. But I'm someone who's seen a UFO for myself. And at no point in my mind did it cross my mind, oh, that's aliens. Like, no, where was I? I was in the desert in New Mexico, near a military base near Los Alamos. Um, and what did I see? I saw some lights flying overhead that moved at a weird speed with a weird color in a weird direction, then zipped off and disappeared. And okay, what does that mean? If you were to ask me to bet, I would say, look, if you were going to tell me something is violating the laws of physics, then you'd better have a lot better measurements of that thing than I saw a light. If you're going to tell me this is definitely aliens, then I need something more than, oh, this thing showed up at my aircraft sensor that looks like a reflection of my aircraft in the sensor. But they said it's a gimbal, so it's got to be like, there are a lot of people, including me, who can see a thing and not know what I'm looking at. But the fact that I don't know what I'm looking at doesn't imply to me it's got to be something supernatural or extraterrestrial. For me, if I don't know what I'm looking at, the solution is someone's got to look at it better. Now, we as astronomers have been monitoring the whole sky periodically over very long periods of time. If we see something that's bright and reflective and moving fast in our solar system, we're going to find it. That's what we see. We have telescopes like Pan-STARRS and the Zwicky Transient Facility that look at this, and that's how we found tens of thousands of objects in our solar system. Now you're telling me that there are aliens out there hanging out in the atmosphere that avoid all of our telescopes but show up on this guy's Navy plane and nothing else ever, and that's where it is? I mean, okay, like maybe, but it's all the same people it's always been, is people who have a story to tell you and want your attention and are going to turn that into some sort of thing. So I would say something that's happening in science communication around the world that I'm not very happy about. It's one of my pet peeves, is you will see a headline that says A says B, where A is some impressive, important sounding title like Pentagon official, Navy pilot, Harvard astronomer, right? Someone you'd be inclined to believe, says completely outlandish fact that is not supported by the evidence at all. Aliens exist. This asteroid was aliens. This light in the equipment was aliens. This, okay, that's great. Dumbass says dumb thing. I'm translating. Yes, you can be Pentagon official, Navy pilot, Harvard astronomer, and still be a dumbass saying a dumb thing. But that's something that happens. That's something that's in the news. That's why, as a scientist, I always go back to that first key question: what is true? Don't tell me what someone says, tell me what is true. Could there be aliens out there? Yes. Do I think there are aliens out there? Yeah, somewhere. Do I think aliens are here? No. Do I think people want aliens to be here so hard that they make shit up to reach that conclusion when the evidence isn't there for it? Yeah, I probably think that.
Makes sense. Makes sense. Good answer.
That's fair.
Yeah.
That's very fair.
But like I said, if I'm wrong, someone's going to come out with the good evidence and show like, oh, by the way, we've been keeping this secret forever. Good evidence. But it's like Ben Franklin said, 3 can keep a secret if 2 of them are dead. So I don't really think that it's very likely that, oh yeah, there's like 2,000 people keeping the secrets of the aliens at Roswell and the Pentagon and all the ex-presidents. Yeah, everyone's kept it secret. And then like, this guy on coast to coast AM radio is telling the real truth.
Right. It's never come out in any of these other leaks that people have escaped with the top secret information. It's not sitting in anybody's bathroom or coming out online or anything.
Right. Keeping us down.
It must be it. Oh, okay. They're the aliens and they're in charge of Got it.
That's right.
I know,
Okay.
and obviously I'm just in cahoots with them. We're just waiting for this call to end for me to rip off my human mask and reveal
that's
the
right.
lizard
You're part of the New World Order. Illuminati, lizard people, Ethan.
Yeah.
That's
what it is.
That's what it is. And we're just being sucked in by your charm and intelligence.
Yeah, I know. It's a surprise I've got you all fooled. I'm really a Toucan Sam under here from Fruit Loops.
I love it. Okay, I kind of want to see that. But we'll have to go to our next question instead. Helen, do you want to ask another one?
Sure. I will ask a question. Okay. So if humans are a part of the natural world, then asking questions of humans is not outside the purview of science. So where the space for ethics around studying us, like intelligence, race, so on and so forth, are all loaded, coded political questions that are in the form of quantifiable scientifically. I'm not sure I said that correctly.
So that's a fine question. You have to understand that there are some questions that inherently asking them is offensive and bigoted. What do you mean? How could I just be I'm just asking questions? How could it, for example, I'm Jewish. If you ask the question, are Jews more combustible than average humans based on incineration at Auschwitz? I would say, I'm pretty sure that's an anti-Semitic question. I'm pretty sure that's an intrinsically anti-Semitic question that you're asking, and maybe you shouldn't be asking it. As far as intelligence and race goes, I would argue that's the same category of question. Do you think we have an objective way to measure intelligence? No. What we have is we have something called an IQ test. The IQ test measures precisely how well you are able to perform on the IQ test. That is what an IQ test measures. We also know that IQ tests are written and biased towards certain races and biased away from other races. So if you ask a racist question and it gives you a racist answer, that doesn't mean your racism is scientifically justified. It just means you fell for a racist trick. So I would say when you are looking into these questions, like, yeah, no questions are off limits, but couching your prejudices in the form of a scientific question doesn't mean it's not prejudice to be asking that question. And I'm not saying you're prejudiced for hearing and repeating the question, but I'm saying that, part of being a swimmer in the ocean means not being ignorant about the existence of sharks. So part of being in a scientific society means recognizing, oh, here are tricks that bigoted people use to push their agenda, and that you shouldn't fall for them.
And like,
Go ahead, Helen.
there's a certain, no, I was just going to say, like, through the study of eugenics, we learned that eugenics was bunk. It was only because we studied eugenics to realize that this is actually bunk science, and that doesn't hold any actual scientific value, because they discover over time, the more they study it, they're like, oh, what, skull size has nothing to do with intelligence. It has nothing to do with, your ability to exist in the world. Same with skin color or anything else. So if you're asking a question, like I'm just asking questions based on race and ethnicity, and how that relates to intelligence or anything like that, it's just a matter of like, well, these two things are not correlated, so why are you even asking the question?
It's also important to recognize that a lot of the places that publish about this are kind of in cahoots with their own little bubble. Like, you're going to see something in the Wall Street Journal op-ed place, and you're going to see that same thing on Mises.org and Cato.org and on Newsweek and on Fox News and on the Daily Wire and on the Daily Caller and on the Daily Stormer, which is the Nazi site, because they're all the same network at some level. They're all pulling from the same group of people, and the same stories are getting pitched by the same group of people to all of these networks. So do be aware of those biases. And there is Fontes Media. They continuously update their media bias charts, and that's an excellent resource. You can always see there's a peak at the top of high quality, little bias, and then there's an extreme right wing where the accuracy goes into the toilet, and an extreme left wing where the accuracy goes into the toilet. And I swear, on the edges, on the fringes, I think it's like some mathematical trick where positive infinity and negative infinity are the same number. Like, I can't distinguish between them on the extreme left and extreme right. For example, Goop and Alex Jones InfoWars sell the same supplements.
Oh, that's horrifying.
That's
Ew.
gross. And then you shower.
Yes. And and on that note, Jason is one of our other co-hosts, and I think he has a quick follow-up to that. So Jason, go ahead and jump in here.
I mean, that was my question ultimately. And I knew it would be a provocative one, because just early on in the presentation, I heard you say something like, you can't be afraid in science to ask any question. And that just made me think about the kind of the ethical quandaries, many of which science has always been embroiled in. And so I just wanted to kind of get your view on this.
Well, this is part of why scientists, especially if you're working with human organisms or any living organisms, there is an ethics review board in everything that involves living creatures. There was, like, at colleges, they have internal review boards. Every specific field has their own, like, no, we can't do this, it's too risky. No, we shouldn't do this, it's not ethical. there's a lot of conspiracy mongering over the origins of COVID-19, and people are like, oh, but this company made this proposal to do this research, and then look, they wanted to do this research, and then years later, this virus came out of nowhere. It's like, hang on, that research that they proposed, that proposal was rejected correctly on ethical grounds. That research was not performed. So, you're like, oh, but then this thing came into, but it wasn't from this, because this didn't get funded or done because it didn't pass ethical review correctly. So, yes, there's lots and lots of research that isn't getting done because it's not ethical, because it was, reviewed by their peers and determined, no, we don't do this in our field, because we are concerned with things like the future of the species and not promoting pseudoscientific studies as actual science.
Now, I think that's a really great point to the way that people hijack science or pseudoscience to serve nefarious interests. And thank you for bringing our attention to that. Also, that media chart. Yeah, that media bias chart.
The media bias, that they'll prop up certain stories, that they'll get like a sound bite and completely ignore the actual years and years of study just to promote a certain idea that serves their purpose. So that's something you gotta be, and it happens on the left and it happens on the right.
Specifically on that media chart, there's a green line. And if you fall below that green line, that's just a good rule of thumb. Like, look for somewhere above that green line that's reporting on that same story.
Yeah, that is an excellent point too, is looking for another place that is reporting this story. Like, if you hear something that sounds completely difficult to believe, maybe double check that on another source. Okay, and we are about out of time. I know. I want to make sure you get to your other appearance as Toucan Sam before it's time for you to go. So I will wrap up with, somebody had a really good question that we can hopefully get your thoughts real briefly on, but I thought this was great. Someone was saying, I was a young Earth creationist until 6 months ago, and now I'm falling in love with actual science, and I'm currently looking into taking online classes at community college as a 31-year-old. Do you have any advice for someone who's thinking of becoming a late bloomer science teacher?
Oh my goodness. I've got to say that is a wonderful path to take. And that if you are, if that is a step that you're willing to take in your recovery from religion, yes, there's incredible precedent for people who have taken exactly that path, for who have done exactly this. There was a book that I read a long time ago by a man named Dr. Morris Seamus. And to those of you who are older than me, you might know him as he was the science advisor to Mr. Wizard. He wrote 800 episodes of Mr. Wizard. That was his minor claim to fame. And he wrote this book called The Myth of Science Literacy. And all throughout my life, I had thought that science literacy was, we're going to ask you this collection of facts, and if you can say this collection of facts, then you're scientifically literate. No, absolutely not. He said that scientific literacy isn't about that at all. What it is about is it's about understanding the role science plays in our world and in human life, and appreciating the advances that science brings to the world and a better understanding of it brings to all of us. And those two key concepts of being aware of what science says about the natural world and what that natural world is, and appreciation for how science plays a positive role in our society, that's the key to science literacy. So I would say, if you wanted to sort of approach that, yes, taking classes, working towards being a teacher, you can obviously do all of that. But I have a feeling that if you are leaving being a young Earth creationist, that reading a book like that can really help sort of synthesize a worldview, a science positive worldview for you to build on that you can then go and bring to your students. I'm a big fan of the better supported the teacher is, the better they will be for their students in the classroom and beyond.
Wonderful. I love that. I'm adding that to my list. I knew you were going to give us good books to add to our Goodreads list, so that one's going on there too. Thank you.
Yeah, it's old. Dr. Seamus has been dead for about 20 years now. But that's a gem that I think is way ahead of its time. I think people are still coming around to that way of thinking about science literacy.
Yeah, that's wonderful. We'll definitely be reading that. And we're definitely going to be having you back. This has been amazing. I learned so much. I say this all the time, but I am going to have to go back and rewatch this to actually absorb everything that you told us about. That was fantastic. Thank you so much.
I knew you'd be a good guest, Ethan. I knew
Thank
it.
you. Thank you, Helen
Thank you
and
for being
Tara.
here.
I'll make one more plug for you guys, because although you will have me back, I doubt it's going to be extremely soon. And I will say, I've been working on a project for the last year and a half called the Encyclopedia Cosmologica, where we start before the Big Bang. And with every turn of the page, you come forward 100 million years in cosmic time with a full illustration and a description of what's happening in the universe and vital stats about the universe and what's in it, all the way until the present day. And just 2 weeks ago, I finished writing the last chapter for this book. So over the next few weeks, I'll be putting this together with the artists working on it and the graphic designer. There will likely be a Kickstarter or Indiegogo campaign to go with it. So
Just bug me and I'll
keep your eyes out for that, because I want this to be a big success. I know we've got a great thing here, and I have a feeling this is the kind of story that people would just love to have in front of them.
I'll pimp it for you, Ethan. Just let me know.
Yeah, send us your stuff, and we'll put it out for people. That sounds like a fantastic resource. Thank you.
Yeah, I have no problem asking for money.
Sweet. Well, thank you so much. Thanks for having me, everyone. Thanks for your attention and your good questions. And remember, science is for everyone, even you.
Oh, I love that. Thank you so much. We'll see you hopefully soon.
Bye-bye.
All right, bye. And we will go ahead and wrap up. We have still some more questions that we didn't get to all the way. We can continue to discuss those in the Hangout time, which we'll go to in just a second. But before we do that, Helen, do you think we should share the results of our opening poll?
We
and see what
should share the results of our opening poll. I think this would be good. And I think we should, like, if you want to give a brief comment on your science education, my science education, that I think that would be good too.
Yeah, I want to talk about that in the Hangout too, like what kind of science education we all got. So here is how people responded to the questions earlier. The first question was, how well-rounded or complete would you say your formal education in science was? 11% of people said very much. The most people, 37%, selected somewhat. 26% of people selected not really. 16% of people said not at all, and 11% of people said don't know, not sure. So it sounds like we've definitely got some gaps in our science education. So I hope this talk was helpful for people that are interested in learning more. And then the second question was, how confident are you that you can access reliable and accurate science information if you want to learn about a specific topic? And I'm really glad we ended up discussing that too. Answer choices were very confident. 32% of people selected very confident. That's great. 58% of people said somewhat confident. Nobody said not very confident, but 11% of people selected not at all confident. So hopefully some of the resources we got here this evening will help with that. And we can discuss more about that too in the Hangout. So I will go ahead and stop sharing that, and we'll go ahead and wrap out, and we'll move to the Hangout here in just a second. But don't forget, we'll be back here next week week, same time, same place, same channel, same link. And we have Matt Dillahunty, who you may or may not have heard of before on the interwebs. You probably have. He will be joining us next week. So be sure and bring your questions for him. It's going to be an interactive show. So I think we'll have a lot of fun. He's a great presenter. And then don't forget, in between now and then, if you need more RfRx in your life, which who doesn't, you can find recordings of our previous episodes on YouTube, on our YouTube channel, or wherever you find your podcasts. And if you have questions, comments, ideas for future shows or topics you'd like to hear covered, go ahead and email us at rfrx@recoveringfromreligion.org. And don't forget to check out the blog and the podcast. Now, Helen, where can people find us on the social media?
Okay, you're all on the socials. I know you all, because you're internet savvy and you're here and you found us. So I know you're on the socials. So if you can go to the Facebook, and go, which I have been informed since I'm on the Facebook, I am old. So if you're on the Facebook, you're old. I've been informed of that. So anyway,
I think that's true. I've heard that too.
Yeah, I've heard that too. So go to Recovery. We have our main page on Facebook, Recovering from Religion. We also have our RfR support groups project, which is also on the Facebook. We are on the Twitter. We are on the Instagram, and we are on the TikTokies. So go like, subscribe, do a heart, share, whatever you got to do the social stuff, so you can help people find out about us and know what's coming up with Recovering from Religion. So do those things, because you're here and I'm going to make you. And if you don't do it, you won't be 20% cooler. And it'll be very sad.
We forgot to ask Ethan about that, but we'll figure out a way to measure
well,
this.
no, I'm gonna do a quantitative study with Ethan about what makes you 20% cooler. I'll make it happen.
Important.
I do things.
Helen gets things done.
I do get things done. Okay, moving on. We're gonna do the feedback poll before I introduce Dr. Ray, because you all know him, so he needs an introduction, because everybody's like, I don't know who this person is. Anyway, moving on. So this program was relevant to me. You need to answer these questions, because this really helps us understand where we're getting our audience and how they're feeling about the show and all that type of jazzy stuff. So 1, fuck you. This was not relevant to me. Why are you talking about this crap? 1. 5, oh my God, this is the most amazing talk ever. I'm so glad I came here. Number 5. 2 to 4, it's a feeling. So check your feelings. The speaker was clear of understandable. For number 2, 1, banana phone. It's like talking into tin cans. I don't understand what the fuck they were talking about. 1. 5, perfectly clear and understandable. They were standing right next to me. I could understand everything they said. 2 to 4, depends on your internet connection and how good your speakers are. So that. 3, I will definitely attend future programs like this. 1, no, screw y'all. You're terrible. I am not coming back. 5, yes, I think you all are awesome and amazing, and I will definitely be back. And I want to be 20% cooler, so I'm going to vote a 5. 2 to 4, check your feelings. And number 4, how did you find RfRx tonight? Number 1, through the best place, the RfR online community Slack channel. 2, through a meetup event. It's fine. Number 3, Facebook, Twitter, or Instagram. Reminds you, if you are on Facebook, you're old. If you're on Twitter and on the Instagram, you are a millennial or a Gen Z. If you are on the Discord, awesome. I hope you found us through there. The RfR website, you are all familiar with us if you're here. So you've been on the RfR website or other, I don't know, you got a psychic message to join us here on our wonderful podcast. And I'm so glad that you're here. So thank you. Okay, so now to wrap up, we're going to have a closing moment with our founder, president, expert on duck penises, Dr. Darrel Ray. Thank you for being here. So, Dr. Ray, bring us out, my friend.
Well, thank you. It's always good to talk about duck penises, although that's not the subject I'm supposed to talk about tonight. But I'll do that again sometime. Anyway, the gods of RfR. I don't know where we found Ethan, but wow, that was a treat. I really enjoyed hearing him, and his passion is just contagious. So that's pretty cool. The thing that I really appreciate a lot about Ethan is, and I wish I could tell him personally, is his ability to tell stories. Science is hard. Communicating science is hard too. And I know a lot of really good scientists that can't really explain to you what they're doing. And he's just damn good at it. I have seen Neil deGrasse Tyson several times and met him a couple of times. And that's the thing about Neil deGrasse Tyson. He can communicate. He can bring it down to anybody in that audience can understand what he's saying. And Ethan kind of seems to have that same skill. So it's not a common skill set because most people don't go into science, to learn how to communicate with lay people. But anyway, I really appreciated that about him today. I will throw one thing or a couple things in. I think in order, I would add to what he said, in order to spot false claims, you have to have a fund of information to start with. So the more you get a foundation of understanding and education on science and specifically the scientific method, I think that's the thing most people don't appreciate. Oh, what's science? Well, science is not a bunch of facts, as Ethan said. Science is based on a very specific method, and it's no one claims it's a perfect method, but it's a damn good method. It's the best method we've got. It's a whole lot better method than going by intuition or my eyeballs tell me that that's a UFO. That's conjecture, that's anecdotal. Find a good understanding of the scientific method and learn it deeply. My biggest influence came when I was in graduate school, and I took a course on science history of science, and we had to read a book called, and I'm going to put this or somebody put this in the links. It was called The Structure of Scientific Revolutions by Thomas Kuhn. Now it's probably a little dated. I'm not going to say it's the most up-to-date book. It was written in the late 60s, in the mid 70s, I believe. Boy, it looks at how science and the scientific method was developed over centuries, because we didn't have the scientific method even 150 years ago. It was not well known and was not well developed. It wasn't until like the 1920s and 30s that it really got highly developed. So no more than 100 years have we had a well-developed scientific method, and it's been getting better and better, of course, and more refined in those 100 years. But if you want to really understand where that all came from, go read the book, The Structure of Scientific Revolutions by Thomas Kuhn. It's in Amazon, and I don't get any cut.